Hello, let's continue our Sudoku adventure with Elbow Grease by Matt Tressel. So this is a debut for Matt, so everyone welcome Matt as a new setter to Sudoku Adventure. That's 2 debuts in a row. All right, so let's go over the rules to this puzzle. We do have normal 6x6 Sudoku rules, meaning in every row, every column, and every 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have quadruples on the grid. If you ignore these arrows, we have these circles with numbers in them. These numbers represent the fact that within the cells that the circle is touching, we need at least one each of each number listed. So we need at least one 1 and at least one 5 in these 4 cells. In these 4 cells, we need to have at least one 4, etc. In addition to that, we do have arrows coming out of the quadruples. Now, for the arrows, we want to read the quadruple as a number. So this would be 15, this would be 12, this one here is 12. And that number is the sum of the digits on the arrow. So, and then you can have 2 independent arrows that happen to attach to the same circle. They're separately summing to that value. So this sums to 15, this sums 15, this sums to 12, etc. And that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. All right, so immediately I see 2 things with this 15. The first thing is we have 5 cells summing to 15. Now, there's a lot of ways to think about this. First of all, you can just know that 5 cells summing to 15 has to be minimum. 1, 2, 3, 4, 5. I happen to know that. It's a triangle number for 5. But also, if you don't know that, what you can know is that the digits in every column, row, column, and box, it's 1 to 6 exactly once each. The sum of 1 through 6 is 21. And the sum of these is 15. So if we do that subtraction, that means that there's 6 left over from 15 to 21. And so that 6 ends up here. So either way, this is a 6, either because you know this is 1, 2, 3, 4, 5, or you know the 21 sum for the column. Now here, 3 cells summing to 15. If you try to max out all of the cells, because we can't repeat any digits, they all share a row, so we can't repeat digits. We're maxing it out. 4, 5, 6 sums to 15. So that is the maximum these can add to. That is what it must be. So this is the 6, because there's already 6 in the box, and then this is a 4, 5 pair. All right, good start. I'm just going to fill the 1, 2, 3 here. All right, so now this quadruple tells us that we have a 1 and a 5 in here. So if we tried to put a 5 here, we wouldn't be able to put a 5 also on the quadruple. So this ends up being the 5, this is the 4. Then we know there's a 1 in one of these 2 cells, but we don't know which one. Okay, what else can we do? 5 and 4 do end up here. I'm just going to mark that. All right, so 3. There's only one way for 2 cells to add to 3, even if they can repeat. If you think about it, if you repeat the digit, it's going to be even. 3 is odd, so this has to be 1 plus 2. That's the only way we're doing that. There's only one way to add to 4 because we can't repeat digits because they share a row, and that's going to be 1 plus 3. We can't do 2 plus 2. What else can we do here? These add to 12. It may be easier to think about the outies here. So if these add to 12, to get to 21, we need 9. So 9 is only 3 plus 6 or 4 plus 5. So I can put 3, 6, 4, 5. This can't be 6, meaning this can't be 3. And that's going to give us the same information as trying to figure out how to get to 12 here. Okay, we also are getting to 12 in 3 digits here. Okay, so that means these add to 9. This is already pretty big. So the thing that I know about adding to 9 in 3 cells is you need 2 cells to be from 1, 2, 3. Right? Let's just use this as scratch. 1, 2, 3, 1, 2, 3, and then we can, and then so 2 of them will be from 1, 2, 3, and 1 will be from 4, 5, 6. If you think about it, if I tried to do even just 4 plus 5, that's already 9, right? So it should be pretty clear that I can't use 2 digits that are in the 4, 5, 6 range. So I do need 2 digits in 1, 2, 3 range, but the maximum 2 digits can be in the 1, 2, 3 range is 5. And so I need at least 4 to make up for that. So we already have our 4, 5, 6 here. We can't have another 4, 5, 6. So these are from 1, 2, 3, meaning this is not 4 or 5. That puts the 4, 5 here. And then additionally, that means that these are from 4, 5, 6. All right. Now, I wonder if we can think a bit harder about this. We can't really, because this could even be 5, 6 with a 1. And that would add to 12. We do need a 1 and a 2 here, but that's already fulfilled. We did that. Okay, here's something else. The 1 and the 2 over here, specifically the 2 is what I want to think about. If there's a 2 in these 4 cells, there cannot be a 2 over here. It's similar to what happened with the 5 over here. In fact, exactly the same. So, because I can't put a 2 here, that would remove 2 from our quad. We're not allowed to. So where does 2 go in this column? The answer is only here. So that's a 2 and that's a 1. That's a 3 and that's a 1. That 1 makes this not a 1. Remember, these add to 9, but I don't think that affects it. We do need a 3 somewhere in here, and this 3 says we can't put it here, and this 1 is occupying a spot, so this has to be a 3. Now these 3s look into this box, placing the 3. So these can't be 3. This 3 makes this a 2, by the way. That makes that 1 and 3. That's a 2. We're deet-deet-dooting in the corner for placing a 3. All right, this is a 1 because we need a 1 in the quad, and then this finishes the box with a 2. All right, we're doing well. Remember, these added to 9. We can't use the 6 anymore because 3 is gone. So this is a 4-5 pair now. Okay, so this has a 6 on it. If you just look at Sudoku here, we must have a 6 here. We also have a 1. That's 7. How are we going from 7 to 12? Well, we need a 5 with that. So this is going to be 5, 6, 1, adding to 12. And that leaves the 4 behind. That makes that a 5. All right, this is going to be a pair for the box. We have 1, 2. We do need 3 and 4. This 3 tells us the order. That's 4 and 3. That 4 gives us the 5 and the 4. This is a pair and this is a pair. So I need a 1, 6 pair here. That's the 6, that's the 1, because we have this 1 here. And we have this pair here, which is 3 and 5. This 3 tells us the order, 5 and 3, or this 5 does. Down here, I need a 2 and a 6. This 2 tells us this is 2 and 6. This is the last digit, which is 4 for the box. Last digit for this column is a 5. That gives us 6 and 5. Up here, I need a 2 and a 6. That goes like that. Down here, I need a 1 and a 4. Goes like that, and we're done. That was a neat puzzle, Matt. Thanks. I really enjoyed thinking about the outies especially, and also I liked being able to use that property of 9 and 3. I think it's an underused property of adding to 9 and 3 cells, but probably there is a way forward without having to exactly think that way, but I really enjoyed using that, and maybe you can add that to your toolbox if you didn't know that. You'd be surprised how often 9 and 3 comes up in various sums. So cool. Well, I enjoyed this. I hope you did too. If you did, then why not leave a like, subscribe, and a kind comment below.